Hey, this is Sir Pasha, and we are on our second lecture of figuring out the compound uncertainty, and just giving you a quick recall of what we studied in our previous lecture. So in our previous lecture we tried to figure out what are the formulas to figure out the uncertainty, and I taught you how to read these equations so that you may apply them. And then we saw one example in which the length, breadth and height was given, and we figure out the percentage uncertainty in volume. And now to understand it further, we are now moving on towards the next example, and that is this. So again, in a question I have been given two measurements. That is, the mass of a block has been measured as 11.5 kilograms with an uncertainty of 0.5. Similarly, the volume of the same block has been measured as 1000 cm cube with an uncertainty of 20 centimeter cube. So that is 1000 plus minus 20 cm cube, and that is 11.5 plus minus 0.5 kg. So here I can write this as that I know the mass as 11.5 plus minus 0.5 kg, and I know the volume V as 1000 plus minus 20 centimeter cube. Now what the examiner expects is that how would you express the density of the metal. Now when they say how would you express the density of metal, they actually want this. That is, they want you to calculate density along with the error in density. Now this is a very good question to understand all the concepts. So this is something that you need to figure out. Now we all know that we can easily measure density using the equation density equals mass over volume. Now we know the mass as 11.5 and we know the volume as 1000, right? So if we try to figure out the value of density, then this value of density is going to be 0.0115, and the unit is going to be kilogram per centimeter cube, because they have not specified that you're supposed to measure this in SI units. So right now I'm keeping this in kilogram per centimeter cube. Now right now I have just figured out the value of density. Now furthermore, what I need is the error in density. Now if I look at this equation for density, which is density equals mass over volume, and if I try to compare this with the 6 equations of uncertainty that I have here, now which of these 6 equations resemble our case of mass over volume? I think you are smart enough to easily figure out that this time we are dealing with this equation, where two measured values are getting divided. Here in this case this is x and y to get u, but in our case I have mass and volume. They are getting divided to get what? To get the density. So now I am going to make my own equation for the error in density, and let's see how I am going to do this. So what I am going to do here is that I am going to write the error in density over density, that is the fractional error in density, equals plus minus the fractional error in mass plus the fractional error in volume. In our equation we have x and y, so it is written fractional error of x and fractional error of y. But in the question that we are solving here, I have mass and volume, so I will write uncertainty in mass over mass plus uncertainty in volume over volume. Now if I further try to solve this, you can see that I don't know the error in density, but I know the value of density here, which is 0.0115. So in place of density I can write 0.0115. I have written the error in density as it is. I have written nothing in place of it because this is something that I need to calculate. And now this is equal to plus minus The error in mass is 0.5 and the actual value of mass is 11.5 plus the error in volume, you can see, is 20. Here this is 20 and the value of volume is 1000. So in place of volume I'm going to write 1000. Now to further simplify, I'm going to write this error equal, you see this 0.0115 is getting divided on the left hand side. When I'll move it towards the right hand side, it will be multiplied with the whole term. So now I can write this as error in density equals plus minus 0.5 divided by 11.5 plus 20 divided by 1000 into 0.0115. And now the final answer that I will get here is going to be plus minus 0.0007. So this is what? This is my error in density. Now always remember that we keep the error or the uncertainty in one significant figures always. This is why I have written this in one significant figure. So the answer is 0.0007 kilograms per cm cube. So now I have figured out the density and I have figured out the error in density. Now I would write the final answer as density plus minus the error in density equals the value of density here 0.0115 plus minus the error as 0.0007 kilograms per cm cube. And this is how I am going to represent the density that I have just measured, and that sums up the whole question. What is important is that the error should be in one significant figure. So you can see there is only one significant figure in the error, and the final answer that you will write must have the same decimal places as that of the error. So in error I have 1, 2, 3, 4 decimal places, and my final answer is has also 4 decimal places, that is 0.115. So you see they both have the same decimal places, and final error has one significant figures, and this is the requirement. I hope this will help you to figure out that how we are going to use these equations to calculate the uncertainty. Alright G, so now moving on to another example. This time I have been given the mass and the diameter of a steel ball. Huh? Alright G, so now moving on towards the next example, and here I have been given the mass and diameter of a steel ball were used to determine its density. The mass was measured within 1% and diameter within 3%. Now what does it mean to say that the mass was measured in 1%? It means that the percentage error in mass is 1. Now see how. See, this is the error in mass. If I divide it with the value of mass, this will be fractional error in mass. If I multiply it with 100, this is going to be percentage error in mass. And this is something that we have been given, that is 1%. So I'm going to write 1 here. Similarly, it says the diameter within 3%. So I would write, this is the error in dia. If I divide it with the value of dia, this is going to be fractional error in diameter. If I multiply it with 100, this is going to be the percentage error in diameter, and this is going to be 3. And now what I'm supposed to calculate is that what is the percentage error in the calculated density of the steel. So again we are going to use the formula of density, and now what the examiner expects from me is to calculate the percentage error in the calculated value of density. So this is the error in density. If I divide it with the actual value of density and multiply it with 100, this will be the percentage error in density, and this is something that I am supposed to calculate. Now, before moving on, the first thing that I need to know is the formula of density, obviously. So this, we know that density is mass over volume. I will write mass M as it is, but because I don't know the volume, I know the dia, so I will write this volume in the form of diameter. So this is 4 upon 3 pi r cube. We know that volume is 4 upon 3 pi r cube, where r is the radius, but because I have been given dia, so I will make my final equation in the form of dia. So see, m over 4 upon 3 as it is, pi as it is. In place of radius, I am going to write d over 2 whole raised to the power 3. Now this expression will be simplified as mass over 4 over 3 pi d raised to the power 3 divided by 2 raised to the power 3 is 8. Now, if we look at the final expression for density, this is going to be m over 4 over 24 pi d raised to the power 3. Now this is the final equation that I have. Alright. Now, in order to figure out the error or fractional error or percentage error, what I need to do is to compare my equation from the 6 equations that I already have. So here are the equations. Here are our references to solve any question of uncertainty. And what we need to do is to compare our case with these 6 equations and decided which of the equations should I use. Now you see, this is my equation, right? This equation for density. Now if I compare this equation here with all the 6 equations, then this formula of density is comparable with this formula. Why? Because see, I have a constant. Here I also have a constant. Here I have 2 or 3 physical quantities getting divided. I have mass and dia getting divided. Here I have Cx, Z getting divided. Here I have a power of 3, and you see here I have power P, Q, R and so on. So I would say that my equation is comparable to the last, to the 6th equation, this one. Now see how I am going to make my equation for the error. I need your high level of attention. I will write my equation as error in density divided by the actual value of density, which is fractional error, equals plus minus the error in mass over mass plus 3 times the uncertainty or the error in d over d. Now you must be wondering why I have written 3 here. I have written 3 here because d has the power 3. So whatever is the power of your measured value, it will become the coefficient. It will be multiplied with the fractional error. You see here, if you see here, x had a power p, you see p is getting multiplied with the fractional error of x. Y has the power q, so q is getting multiplied with the fractional error of y. So whatever is the power, it will get multiplied, and if there is no power, it means that you have power 1. So I will multiply it with 1, so I need not to write 1 here. If you see, the power of mass is 1, so I need not to multiply 1 here, because obviously this is needless. And now you must be wondering, what happened to this constant? 4 over 24 into pi. See, while figuring out the fractional error, the constant is ignored. We do not consider the constant while figuring out the fractional error. You can see here in this equation, I have a constant in the equation, but while figuring out the error, there is no such thing as C in the whole equation. Why? Because we ignore the constant while figuring out the fractional error. That is why I have ignored my constant, which is 4 over 24 pi. Now, when I am successful in figuring out the equation for the fractional error of dia, if I multiply this whole equation with 100, I will be able to deduce an equation for the percentage error of dia. So you see, if I multiply this error in density over density multiplied by 100 equal plus minus error in mass over mass multiplied by 100 plus minus 3 times error in d over d multiplied by 100. So what I have done is that I have multiplied the whole equation with 100. Now this will help me figure out the percentage error. Now this is something that I need to figure out. So I leave this as it is. Now this is the percentage error in mass. So I know the percentage error in mass here. This is 1. So in place of all of this term, I am going to write 1, because the percentage error in mass is 1. So in place of this whole term, I am going to write what? I am going to write 1 plus this 3 is going to be written as it is multiplied by this whole term, percentage error in d. We know this has been given in question, and this is 3%. So I am going to write 3 in place of the percentage error of d, and now you can see 3 times 3 is 9 plus 1 is 10, and the answer is, so I can say that the percentage error in density is this, and this is 10%. So this was a little tricky question, but I hope this would have helped you understand how we are going to use these equations to figure out the uncertainties.